All right, so I think we'll go ahead and get started. Welcome back to the 2022 Ottawa Hockey Analytics Conference. I need to remind everybody that we are recording, and so questions and all of that is getting recorded as we are going here. The next session is we've got NickWan digging into some of the digging into some of the Big Data Cup data. And so it is my very distinct pleasure to introduce Nick. NickWan is in his 4th season with the Cincinnati Reds and 1st season as Director of Analytics. In his role, Wan oversees the day-to-day analytics operations for the Major League team, player development, health and performance, professional scouting, and amateur scouting. Wan previously spent 3 years as a data scientist with the Reds, developing analytics for the Major League team, player development, and mental skills. He returned to the Reds this year after spending 1 year with Kentucky Fried Chicken as the manager of data science, where he built out data science capabilities for the U.S. operations. Wan earned his PhD in psychology from Utah State University, where he studied the neuroscience of social strategies, and earned his BS in psychology from St. Mary's College of California. He is also the game show host for Sliced, a competitive data science competition, which is streamed on his Twitch channel. So my pleasure to introduce Nick. Nick, the floor is yours.
Thank you, Shuckers. And thank you everyone here at letting me do this walk through the data. I tried to turn my video on. I swear I did, but my video is like really laggy. So is that okay? Is that okay? We we do it that way.
Yeah, I think it's great, Nick. I mean, I think go ahead and just talk through it. I don't think we need to see your face. Just hearing your voice is enough.
Okay, rad. Thank you, Shockers. Thank you everyone for letting me be a part of this. I was a participant for Big Data Cup last year, and me and my group, who was composed of Sean Clement, Ethan Douglas, and Ian Greengross, we had a really fun time doing this, and so I was so excited to hear that not only are we doing it again this year, but I was asked to help present and help unveil, if you will, the data set. So my presentation is going to be more about just walking through the data set, seeing what we got, messing around with some of the data, seeing maybe coming up with a roadmap or some ideas of things that people could potentially do with this year's Big Data Cup data. So as it was mentioned earlier, you guys all, you all have the data set is over at StatLeets. And it is this GitHub link here, which it gives you the submission guidelines. It tells you all about the data. And what's nice, which was a little difficult for me as sort of a novice to the hockey analytics world, is that there's a pretty good data dictionary and what all these columns mean. And coming from a world of baseball, coming from a world of NFL analytics, it is nice to know sort of all the different things that's happening in these data sets, especially if we're trying to create predictive models and explore any edges or any advantages we could glean from play-by-play data here. So we have all this data. I have taken the liberty to download the Git, just clone the entire repo. If you're unfamiliar with how to do that, that is literally just a git clone the URL. So I put that over into our Google Drive. And so I'm just going to be accessing it just like if it was on my Google Drive or just like it was on my desktop. So I'm going to import a few libraries here. I was informed that there is no conference chat. Is that right? There's no conference chat. So I can't sort of get live feedback from people. if they wanted to ask questions about anything, but maybe that's okay. You know, that might keep me like just focused on live coding here. So,
Nick, I'm going to interrupt you.
Okay.
There is a Q&A.
Oh, there is.
Where folks can put their questions.
Okay.
So I will, hopefully you can peek at that every once in a while, but if it backs up a little bit, I'll interrupt you.
You know what? I got the Q&A popped up now. It is visible. It's in my sights. Thank you, Shuckers. Okay. So I'm going to load in some plot. Oh, okay. This is wrong. This isn't even a thing. So I'm going to load in some libraries here. If you're not familiar with Python and the Python environment, this is sort of the bomb squad here, y'all. Pandas, NumPy. This is what we'll be using for numerical data or tabular data, similar to your typical R data frame and dplyr packages, libraries, and then matplotlib and Seaborn. Of course, if you've seen my new game show, VizBuzz, you will know that Python and DataViz goes a lot through Seaborn and matplotlib and has been handily defeated in the last 3 weeks by ggplot2 users. So R people out there, you got one on me. You got one on us. Okay, so we've loaded this in. I believe. Oh, let me make sure I could see. I got to make sure this path is right. I don't want to like dox myself, Stir. This is all Python, or this is all Google Drive. So Drive, my drive. I put this in 2022 BDC. So let's see. Okay, this is I cloned it into this thing. So this is big data cup. Okay, never mind. Don't it's okay. Cup 2021. Okay, so here's this is the same thing as all of the data that we're seeing here in the GitHub. You could see that we even have the markdown files in here. And so you'll see all of this data, all this structure, and the tracking data in there as well. We have all this, and then you'll see here in the tracking data, that's a folder in here. And so we'll be taking a peek at that as well. But let's just load in a few of these CSVs as we see it. Let me set this, let's make sure that this is my project directory, project, dir. Oh God, what am I doing? It's okay. It's okay. I code for a living. Okay, y'all. Okay. Let's see. So we're here. Let's also take a look at the data that we're going to have in our project directory. Please. I have this like tragic laptop that I'm working off of right now. This is like, you might notice that the room that I'm in is like very reverb. It's as if there's a lot of reverb in this room. That's because it's like a brand new place. It's like someone just moved in today, it feels like. So okay. So this is the other data set, and this is all tracking data. So this is like computer vision data is what I'm guessing this is. So let's load in a few different data sets. First, let's load in, we'll use pandas for this. Let's load in projector, and we'll load in our Olympic data here.csv. Okay, let's bring that in. And let's take a look at how much data is in this. This is 10K rows, 10K and some change. So if we want to take a look at just a handful of the rows here, just a random sample of rows, we could take a random sample of our data frame. We use pandas to load in our data set here using read CSV. We dropped in our CSV, and now we're just taking a look at a random sample of 10 rows here. And we have this looks like, oh God, where's the scroll? Does this not work? Okay, that's fine. It's okay. Okay, it's actually not okay. It's too many rows. I'm on a laptop, I can't see anything. Okay. This is our, as it says, it's play-by-play data. This is Women's Olympics 2022, and it gives us who the player is, the event type, and all the different details about it. And then all the different stadium information, the type of situation we're in. If we want to take a look at the columns in this data, we could take a look with columns.values, and we see all these different things. And so you can see that we're only getting a handful of the columns. Not all 22 columns are represented here. You could see there's like an ellipsis. Is that what it's called? Ellipsis right here. From goals against, which is here, all the way until event successful, which is over here. We're missing these two columns, the player name and the event. So if we wanted to just take a look, say at a handful of these columns, we could use this using the .loc function. Let's just take a look at these, sample through, and you can see different player names, the events that were happening. X and Y is where they are on the rink. Remember, X and Y, it's the top down X and Y. And then if there was another player on the play, so for pass plays or assists, you could see who the secondary player was for this. Okay, and if you were doing anything with Big Data Cup last year, you are probably very familiar with the play-by-play data here. If you're not familiar with play-by-play data, if this is the first time you've been to trying to register for Big Data Cup or doing anything with Ottawa Hockey Analytics Conference, the idea of play-by-play data is truly like that rich data that you could start informing things like XG, things like the value of a pass, things like the value of defensive plays. A lot of it stems, or at least begins, starting out with some sort of play-by-play data. However, we apparently have even more rich data with our tracking data. So that's this data set here. So let's take a look at the tracking data we have available to us. And we'll do this too. We'll call this tracking data. We'll do this just the same way. So read CSV my gigantic fingers are, this keyboard and my gigantic gorilla palms and sausage links on my hands are just like stumbling over these keys, but that's just, that's just a me thing. Let's go tracking data. It's tracking data. Someone asked, what do you look for when you analyze data in a sport I'm fairly new in? And I am fairly new at hockey data. Hockey is definitely, the only time I've ever done a really in-depth project with hockey before it was Big Data Cup. And so when I'm looking at a new sport, I'm not necessarily unfamiliar with any sport. I remember once some years ago, we did some pro bull riding data on my stream. That's twitch.tv/NickWan_datasci. But I was really unfamiliar with pro bull riding. So I actually had to spend like an entire hour or two trying to learn the rules of pro bull riding. At the end of it, I did inevitably figure out not just the rules, but things that would be important to estimate, like how long does a rider stay on a bull? How much does a rider in a bull score if a rider makes eights? So really, I think it starts with the question of like, what's the scoring system of the sport, and how can you estimate or at least provide a more accurate representation of everyone who is involved in the play, the value of that play given the scoring opportunities or the scoring chances from a team. And of course, in hockey, XG is such a valuable statistic. Everyone has some sort of XG model. Sometimes they're extremely specific down to the N by N matchup, depending on how many players are on the ice at the time, or even as far as like N by N, and then also available bench players. It could get pretty specific, but it could also be pretty broad. For example, just like in the NFL, you could just take the game state and create some sort of win probability model. So given the goal difference, the time, the period, you could create a fairly simple, but probably somewhat accurate win probability model. So depending on how you want to tackle the first question you ask, my usual first question is, what's the value of a goal, or what's the value of a win? If y'all are like, what is this guy talking about? It's okay. That's what everyone says. So here we are with some tracking data. And this tracking data here, this is one of like several different CSVs in this folder. So this is Finland at USA on Feb 14 this past year. And this is, I'm guessing period 2, power play 1. Is that what this means? Hold on, let's refer to the doc, okay? Let's refer to the doc. Tracking data and documentation here. Would you look at that? Would you look at that? Oh my God, look at all this crazy. Oh my, this is craziness. Okay. Okay. Tracking event coordinates. Wow, this is great. I probably should have read this. Tracking coordinates are relative to the rink seen from the broadcast camera. Only players within the field of view of the broadcast camera are visible at any time. Detection is only performed for video and main broadcast cameras. Skip frames are in the data likely mean the camera angle switched. Oh man, all those replays that are messing up my play-by-play tracking data. Okay, that's fine. So what we have here is frame ID, the period that the index of the player track does not correspond to the jersey number. Okay, light or dark. So given the whether a team was either home or away, or what team uniform a particular team was wearing, light or dark. The team name, the jersey number detected, jersey number of the player. Players with 100 means no jersey number was detected for that player, and then position. Okay, so this is frame by frame data. Okay, so and that is this is specifically one, I guess, power play in this case. So power play here. Alyssa is telling me that this is power play 1, period 1. I want to say P2. Is that right? Are we indexing in a way that I don't know? Okay. So if we want to take a look at sort of more rows in the first part of this, we could do a head 20. And so you can see that this is all frame ID 1, and this is each player within the broadcast frame. So this is track ID. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 10. That's because 9 is probably the goalie on the other team that's out of frame. So that makes sense here. Okay, so we have frame ID, and then each frame is tracked, and that's frame ID is tracked in time. Does this give us an idea of how often it's tracked in time? Does anyone know? Can anyone tell me before I spend time reading doc while people on this conference call are patiently waiting for me to do something other than look up the tabular data? Is this how long is 1 second in this data set? How many frames are in the data sets? Okay, it's okay. Let's just isolate one. So I'm just going to isolate one player in this entire data set. Yeah, all right, Pascal, how many frames per second are we getting here?
30.
Seconds per frame, maybe.
30 frames per second.
30 frames per second. See? Okay, that's great. Thank you. Okay. There you go. Thank you. Okay, so let's isolate a player here. Let's see, track ID. Let's just take one player here. Track ID. Let me make sure I'm doing this right. Index of a player track detected. This does not correspond to the jersey number of a player, but rather a unique identifier of an associated sequence of player detections. Okay, so this might not exactly be a player. This could be a different players. I guess we could check for that. Let's see if jersey number is this. Let's see, team name. Is it team name, and jersey number. Drop duplicates. What do we got? Okay, so this is one player. This is USA's number 6. Who's USA's number 6? Anyone out there know? I don't. I'm sorry. I don't. Okay. So we can take this player and we can take all of the XY locations, X feet, Y feet, and let's put this into one player. Let's just make this a data set called one player. And let's also do frame ID. Frame underscore ID. Okay. It's all right. There are some folks who are back channeling info to me, and I'm like, it's okay. Never mind. Don't listen to me. Actually, you have to listen to me. Hi. Let's go line plots. Data equals one player. And then let's also do X equals X feet. Let's go Y equals Y feet. And let's see what this looks like just on a line plot. Okay. This looks pretty crazy. Hold on, let me make this also larger. Fig equals plt.figure, fig size. We'll do this 10 by 10, 10 by 15. 15 by 10. It's all right. Okay, so oh, and the rink size itself. Okay, and we saw this before. They are giving us a rink to plot on, and the y coordinates are 0 to 98, and then 0 to 200. So we should plot on those specific coordinates. So plt.xlim, we should be using the xlim of 0 to 200, 0 to 200, and then plt lim, we should be using 0 to 98. Okay. And plt show. Okay. So this is all the data that we have just from this one player. But this one player, of course, yeah, we don't necessarily know what points over time this is. A line plot might not be the best plot for this. So rather than connecting all the dots here, let's use a scatter plot. And here's what the scatter plot looks like. And so this looks a little more logical as to a path of a player. As a player perhaps begins or ends their time in this play. You can sort of start tracking what that looks like here. There is a loopy loop here, as Alyssa has told me, in the back alleys of chat here. Yeah. Okay, interesting. So if we wanted to isolate more players on this play, for instance, if we want to start including not just track ID 1, but say we wanted to do just 2 players, let's say is in So we have track 1, and let's also include track 2, track ID 2. And then let's also include a reference for that track ID here. So when we have our data set, and we'll just look at the top 3 rows here, you can see frame ID, track ID, and then their X and Y location. So now we'll use the same scatter plot, but I'm going to make track 1 hue or color, and I'll make track 2 a different hue, and I'll use that with track ID. Okay, so now we have, and let me clean this up a little. So now we have our data set, our X and Y, and then hue will be track ID. And you might be wondering why these are all strings. It's because these strings are referencing the data set here. This data set we're creating from our tracking data. Our tracking data we loaded in from the CSV that's coming straight from the GitHub link. You can check out that GitHub link with that link to the Big Data Cup. Check out that GitHub repo for all the data. So let's run through this now with 2 players, theoretically, on this pass. So here's 1 player. This is kind of light. Let's change this palette. Let's use the bone color palette. There we go. Oh gosh, this is still very light. Okay, let's use paired. You might be wondering, like, how does this person know all these color palettes? It's because I'm a very old person who knows all the color palettes, all of them, every single one, even the ones that haven't been created yet. I know them all. Okay, so you can see that this is 1 track of a player, and this player is on USA, number 6. Another player that we're looking at is on USA's team, track ID 2. We're just assuming this is all data from USA 24, who takes a different path during this power play. Okay, what if we wanted to take a look at everyone on the US team? So rather than just doing the track IDs for 2 players, what if we just wanted to isolate all the members on the US team? Let's use the team name instead. We'll take all the data for anyone related to the team name here equals a USA. Everything here, that's good. We'll run through this. We'll still use track ID just because we want separation between different players on the US team. And when we plot this, oh goodness, what is going on here? This looks like something that you would put on like accidental art. Y'all know about accidental art? Hold on. Let's just make sure we could see all the data. You know, B box to anchor equals 1, O2, 1, location 2. You know, we don't want the legend sullying our plot here, which is this. Here we are, and you can see this faint blue in the background, that track 1, which has that little loop-de-loop here, and it comes out here. You could see that we have some consistency from player 1, and player 2 is probably this blue line over here. But as you can see, as the doc has said, track ID, the index of the player track detected, it will not correspond with the jersey number of the player, but rather a unique ID for the associated sequence of a player's detection. So that's why you see a lot of different player tracks, more than just what you have in terms of players. So if we wanted to get out of that, maybe we could just use jersey number instead. So let's use jersey number instead. We'll put jersey number in here. See, you know, what's the Bob Ross, or what's the Bob Ross saying? It's a beautiful accidents or something. Okay, this definitely cleans up in terms of the number of different players But we still have a pretty large amount of numbers here, which probably corresponds with like shifts that come in, right, throughout this power play. Happy accidents. Thank you, Marshall. So we do see that there is tracking data abilities here. It is fairly large. Each data set for, and this is just one power play in one period, right? This data set alone is 9,500 rows, just shy of 9,500 rows. Each of these data sets, I'm guessing, vary within the thousands to probably larger than that as well. So this is pretty amazing, just because if all of you have taken note of the Big Data Bowl, which also uses tracking data, you could see that there's a lot of insights to be had at every possible point in terms of anything from drills or anything from the translation of drills to speed, or the translation of speed or things over time to actual playmaking abilities. We can start quantifying things on a more granular level, not just at a play-by-play level, which we showed that there is data for play-by-play, which will also be valuable just to know what events are happening over time. But now we have even more information about the things happening between each event, between each play-by-play event. So that's really important in this data set, to be able to link the things that are happening between events. Okay, cool. Let's see, what else should we dive into here? What else am I missing? We have the tracking data, which is pretty amazing. I made some horrible plots. That's good. What else can we play with? What should we play with, chat? Let's see. What can we do quick with our tracking data that perhaps we can do in conjunction with our play-by-play data? There's also other data sets that we have in here. For instance, we have this hackathon women's data. Okay, let's see. Let's just keep taking a peek at different data sets here, just to see what else we got going. Let's see. Maybe we have. Oh wait, this hackathon data is. Oh, hold on. This was 14 months ago. This is the last Big Data Cup. Okay, let's not look at that. We've done that before. Here we go. Power play info. Okay, so let's take a look at the info. How's everyone doing? Is everyone good? There's not another Q&A right now. Y'all are free to ask questions, you know. PP info. Okay, tracking data. Let's see. This is going to give us all of this info. So timestamps and the starts and ends. Okay, so this is good just in terms of being able to perhaps give more context to what's happening. And I think this might be able to help us join stuff probably. Index of the shot. Okay, so we have shot info. So game video shots info power play name. Okay. Game. Where are we? Tracking data. Video shot info. Okay, so let's load that in too, because that will be something we could actually join on, right? What am I doing here? Okay, tracking data, and then we'll do this with tracking data info. TD info. Video shot info, and then the game. Okay. Shots refer to video shots, not shots on net. Okay. I'm learning here, okay? So these are things we learn. Things we learn when we live code. Okay. Okay. These are actually frame shots. Okay, so we do have the play-by-play data though, which is this. Someone has asked me if I can show an animation of this. I can't do that too quickly. Not in the time. Well, oh gosh, we would use some seed code. We would have to use some seed code as opposed to just doing it live. We could do that. It'd be a lot of errors though. Okay, maybe I'll think about it. Okay, so we have our DF head, then we have our frame period, and then track ID. Okay, so let's see. How would I want to join this? How would I want to join this? First, we should isolate down the data set. Okay. Let's go game dates. And we'll go 8, or sorry, not 8. This is 2, 14, 2020. This is it. This is how I do it. Is that the game date? Okay, that doesn't exist. No, what am I doing? What am I doing wrong? What data set did I grab that I shouldn't have grabbed? Someone help me, please. Okay, it's okay. It's okay. Well, I think, is this right? Does this make sense? Am I in the right, is this correct? Pascal is like shepherding me through this right now. Oh, it's this. Okay. I got the order wrong. I got the order wrong. It's okay. I read 8-2 as 2-8. I'm sorry. It went day, month, year. You know, I'm from America, okay? Month, day, year is just something that's so common for me. Okay, month, day, year is just a thing that I'm used to. Okay, here we are with the events. We are in period 2. And again, y'all, if you're seeing me run through this data set and you're like, you know what, I could do better than that guy. You can. In fact, I challenge you to. I dare you to. Just go over and download that big data cup data set and start messing around with it. You know, the more you're able to show and showcase your abilities on working with tracking data, if it is something you're passionate about, if you are an enthusiast, if you're a hobbyist, or if you're someone who's looking on the outside, looking to get in to sports analytics, whether it's hockey analytics that you're interested in, or whether it is NFL or baseball or basketball or whatever sport, tracking data is it is the next frontier for many of sports, and it's really important to understand what kind of data that looks like and how you could sort of glean information from that tracking data. A lot of teams need people who are able to, at the very least, understand how tracking data is organized, let alone how you can extract functional, informative information from tracking data as it relates to in-game performance. So the more you're able to do that, in my opinion, the better your chances are in excelling through those interview processes and ultimately landing a job. As you have seen from the Big Data Cup, tons of people have landed jobs just from being able to compete and put together an end-to-end project. They're not even the people who are the winners or the finalists or the honor roll mentions. People use their projects in the Big Data Cup just as portfolio fodder, and it becomes the thing that we talk about in interviews. So for me, as the director of analytics for the Cincinnati Reds, if I see someone with a Big Data Cup or a Big Data Bowl entry, that's the project we talk about during their panel interview session, hearing it from them, how they walked through from beginning to end, and all the different things that all the different things they tried, how they linked data together, how they extracted information from it. It's an important piece and step in the right direction if you are interested in a job in sports analytics, especially sports analytics for a team. Someone out there is now telling me that I said the word Excel and data jobs, and now they are trolling me for it. So true and real. Excel, like in, okay, never mind. Situation type. This was a power play. Oh God, what did I do? Is it 5-on-4? Is that what this is going to be called? Oh yes, situation spelled with 2 U's. I knew that, I was just testing y'all. Okay. Power play 1. Okay. How do I know if this is the first power play? I don't. This is probably where the time comes in. Pascal, how do I know if this is the first power play or not?
You probably have to look at the shots CSV for each of the power plays.
See,
start and end.
That's exactly why I loaded it in, That's, I was like, I'm gonna need this file. This is why I needed it. Okay.
Hey, Nick, it's Shuckers. Couple more minutes, and then we need to wrap it up. As much as I am sitting here enjoying watching you do this.
Okay, actually, I'll answer one more question, and then if there are any other questions, well, we could open up for question and answers too. But there's one question here. What are important things to look at when cleaning data like this? The big thing that you're going to come into for data like this is making sure that your joining data is true. So right before we wrap up here, what I was doing was trying to isolate the period and the situation type. In this case, as we know, this was a February 14th game, Finland versus the US, period 2, power play 1. We were about to get there, and it was going to be magnificent. It was just a majestic, perfect join and no flaws at all. But I didn't get to show that off. However, for you and for the people out there, you may question whether your join makes sense. You may have more rows than you expected. You may have less rows than you expected when you start joining data. I would say a difficult part about this project is making sure that when you do your joins, you're joining on the right events, doing the right things. So people who are playing around with the Big Data Cup data this year, make sure that you're joining the right events, the right play-by-play data to the tracking data correctly. And of course, with any of these hackathons, with any of these types of events, please have as much fun as you could possibly have. These things come, once a year, and it's so fun. Get a group together, have just the clear time for it. order some pizza on the weekend, bring your friends into some, living room, have yourself, a data science LAN party together. Do they have those things? Whatever. But I do challenge y'all to explore the data just like I did tonight. Take a look. There's so much data here. It's pretty amazing. So I'm excited to see what everyone comes up with this year. But thanks for having me on again. If you're interested in following along my journey as I explore more of this data set, you could do that over at twitch.tv/NickWan Data Sci, in which I am actually live right now. So feel free to go over there and check it out if you want. But with that, I'll pass it back over to our organizers. But thank you for having me on, y'all. Have a good evening.
Nick, Shuckers here. Thank you so much for that. It was a blast. And I think it's really great to illustrate sort of some of the things you can do, but also, some of those processes that those of us go through and mistakes that we make, even those of us who, do this for a living. So I really appreciate your willingness to do this, and on behalf of everybody, thank you for doing it. And I guess thanks to all of our speakers this evening. I guess remind everybody that we're going to start again tomorrow morning. We'll start at 10 o'clock Eastern with an opening and a welcome, and then we'll have a little bit more discussion shortly thereafter on the Big Data 2 competition. The program is over at the conference website. And with that, I will, thank all of our speakers from tonight. I think it's been a great start to the conference. And I'll turn it over to Shirley, some final notes.
I just want to thank everybody for attending, and look forward to having you come on board tomorrow morning at 10 o'clock Eastern time. We have a full day planned for you, so hope you are bright and bushy-tailed in the morning, and see you then. Thank you.